Excellent. Hello.
Yeah. So nice to have you, Evangelos, on the stage. And yeah, we're really looking forward to a presentation about roll-to-roll high manufacturing of OPVs here in Europe. So
Thank you
very
for
nice.
inviting
So,
me here.
no, our pleasure. So whenever you're ready, please share your slides.
Yes. So, hi everyone. I'm Evangelos Mekeridis. I'm the CTO of Organic Electronic Technologies, and today we will speak about the roll-to-roll high volume manufacturing of organic photovoltaics. So, this is the outline of my talk. We will start with a short introduction of organic electronic technologies. We will speak about the printed OPV smart manufacturing and the targets for going to mass production. And finally, I would like to show you some products and demos of OET. So, OET was founded in 2012. We are a nanotechnology-driven company. We bring more than 35 years of experience in thin film technologies and more than 23 years in flexible print electronics. We are producers of roll-to-roll printed organic photovoltaics over a large area, and our expertise is based on roll-to-roll manufacturing of flexible print electronics, and especially in organic photovoltaics. We own patents and IPs in roll-to-roll manufacturing, inline and real-time metrology tools, and inline laser processes and OPV applications. And to prove our, let's say, concepts, we have built more than 40 demonstrators and pilot installations. So what we do, we manufacture organic photovoltaic panels. We can provide energy solutions based on organic photovoltaics. We can manufacture organic light-emitting diodes for lighting and provide a combined solution of energy and lighting solutions. And also with our sister company, BL Nanobiomed, we have worked on printing biosensors. Our mission is to open the OPV market and deliver highly efficient OPV products integrated in agriculture, infrastructures, and building elements with high aesthetics, aiming to energy-positive buildings and climate-neutral economy. So our vision is to have sustainable electricity from any surface and everywhere. Here is a picture of our team. We are a short team, but we are growing. So the question is why OPVs? The significance of OPVs is based on large-scale roll-to-roll printing, as it was well said from Mr. Thomas Kobles in the previous presentation. They can be produced in low cost. They have a performance of around 20% according to NREL latest results on lab scale. They can be made semi-transparent with a variety of colors. They have a freedom of design. They are thin, flexible, and can be applied in any surface. There is a growing demand for clean energy solutions. The materials can be recyclable and have a minimal CO2 footprint. So let's go to smart manufacturing. In our roll-to-roll process that we use, basically we start with a slot die coating of the layers. We use quality control tools to monitor the wet coating. Then we dry our layers. Then we use quality control tools to monitor our dried layers. We use laser patterning, of course, to isolate the cells. Then we use quality control tools for laser scribing. Finally, we laminate, encapsulate our photovoltaics, and we use quality control tools also to monitor the performance of the final product. Here is a series of some quality control tools and process tools that we use. So the main target for us is to transform the traditional manufacturing and industrial practices by combining the latest smart technology to use large machine-to-machine communication and IoT in order to provide increased automations, improved communications, and self-monitoring, so finally to have smart machines that can analyze and diagnose issues without the need of human intervention. For this reason, we use a unique roll-to-roll printing pilot production line that is based here in Thessaloniki in LTFN, and we use smart manufacturing by closed loop with inline real-time metrology and quality control and pulse laser patterning in order to go to Industry 4.0 concepts and have near zero defects, increase the yield, decrease the material waste, have high reliability and precisability, and reduce the production cost. And we would like to use non-toxic materials and environmentally friendly processes. Of course, we needed to build our in-house equipment as well to support this manufacturing. So we have built an automated coating station. It's a 4-axis coating station for slot die coating with a supervisory control and acquisition system with a vertical axis accuracy of 1 micron, rotational axis of 10 microns, and horizontal axis of 10 microns.